4.5, continuing. Let's look at examples. So number 4, given y double prime plus y prime equals 1, and given a particular solution as y of t equals t, find a general solution. You can see that this is a particular solution. If you just do its derivative, you get 1. Its second derivative is 0, and so 1 equals 1. I mean, it's that simple. But there's other solutions, of course, and that's when you look at next the homogeneous case, and then essentially you're using the concept that we already know, well, that we just learned. The superposition principle says the sum of those is also a solution, which you know that because you know a particular plus the homogeneous is a solution. But this allows us to kind of use another concept. All right, so here we go. So where did I go? So find the general solution. So where we start is the associated homogeneous. So the associated homogeneous equation. And then convert that to, like we did before, r squared plus r equals 0. So I'll go ahead and factor that. Not like that, though. I'll r first. Okay, so r times r minus 1 equal to 0. So we have r equal to 0 or r equal to negative 1. So then we can calculate the homogeneous solution by the previous methods because it's linear. These are linear case 1. And so we have this. So the homogeneous solution is so y sub h of t is c1 e to the 0t plus c2 e to the negative t. Right, so that's just going back to, I think it's like 4.2, something like that. And we'll simplify that a little bit. That's just, of course, c1 plus c2 e to the negative t. So, and then we add the particular solution to the general solution, which, again, we already know that, but that's essentially the superposition. You have one solution of f of t equals 1, and another solution with g of t equals 0, which is homogeneous, but it's still a solution. Okay, so then I'll write it out. So we have the general concept, and then we add the particular solution to the general solution. And so you get y of t is the general is y particular of t plus y homogeneous of t, which is, what is that, t, and then plus c1 plus c2 e to the negative t. Okay. Next, look at example 8. All right, so example 8, given the equation y double prime equal to 2y prime minus y plus 2e to the x, and y particular is given to be x squared e to the x, fine, a general solution. So first we want to write that in standard form and then find the associated auxiliary equation. So this back here is really like the auxiliary. Or characteristic. All right, so let's see. So now we're right. So first write in this form. So y double prime minus 2y prime plus y equal to 2e to the x. Okay. Then you, of course, just have r squared minus 2r plus 1 equals 0. So that's our auxiliary equation, r squared minus 2r plus 1 equal to 0. That factors to difference quantity squared, r minus 1. So it looks like we're getting r equals 1 with a double root. So if you get r equals 1 with a double root, so the homogeneous case then is the, you have to put the x in front of one of the e's. So it's c1x e to the x plus c2 e to the x. So that's, remember, that's again, I'm just going back to the previous stuff to substitute in. So you get this x in there because it's a double root. Or when we did it, we probably had t. Okay. So where are we at? Okay, so now add the particular and the homogeneous. Okay, so then you get y of x equal to y particular of x plus the homogeneous of x. So it was given x squared e to the x, and then we just found out c1x e to the x plus c2 e to the x. All right, so those are kind of simple cases, just demonstrating the principle. Now let's go on to 18 and 20, which we got to find the particular solution. So let's take a look at that. This is number 18. So number 18 says, find a general solution to y double prime minus y equal to negative 11t plus 1. So first we look at the homogeneous case. The auxiliary equation is r squared minus 1 equal to 0 if and only if r is equal to plus or minus 1, of course. Hence, y of t, that's the homogeneous, is just c1 e to the t plus c2 e to the negative t. Pretty straightforward. So that is a general solution to the homogeneous case. So now we need to find a particular solution to the given equation, right? To this one. So find a particular. So the way we can do that is use the method of undetermined coefficients, like the previous section. So we're going to apply the method of undetermined coefficients. All right, so y particular of t. So let's see, I thought I wrote that out. So basically, yeah, I mean, if you have this form, that's just a polynomial, and your solutions are plus or minus 1 to the homogeneous. Your m up here would be 1, and any of your e's are 0, right? So you just get this form. So look this up again, but you just get AT plus B. And that's because when you do the undetermined coefficients, this is one of our special cases, and it's just linear. It's a polynomial. There's no e in it. There's nothing else. So I think it's your r is gone, right? So it's not there. Your m is 1. Okay, so check that out. So then we'll have to do y prime, and you get just a, and then y double prime is just 0. So then you have to set them equal. So now we set this equal to this, substituting in, and then equate coefficients. So you have y particular double prime minus y prime equal to, and then your y double prime is 0 minus at minus b. Okay, so that's equal to negative at minus b, which is negative 11t plus 1. And so now you equate coefficients, which is the point of the name of it. It's undetermined coefficients. Now you're equating them to solve for them. It's basically what you're doing. So you equate coefficients, and we have a must be 11. And what's b? B must be negative 1. So y, the particular then, is 11t minus 1. And then by the superposition principle, you add those together. Y of t is the particular plus the homogeneous. So it's 11t minus 1 plus c1 e to the t plus c2 e to the negative t. Okay. Well, we have 2 more. We'll go ahead and do another video for that.